We have another example on the board. Please notice that we are talking about the series circuit. In series circuit, the current at every single component is the same. That's why I'm supposed to write that I total is equal to IR, this is also equal to IL, and this is also equal to IC. So I can say that my I total is equal to 100 milliamps. Please notice that my voltage source is RMS voltage. And I'm going to assume that my current is also RMS because it's not specified in different way. So this is also my total current according to the KCL, Kirchhoff current law for series circuit. This is equal 100 milliamps. So Z total is equal voltage source over I total, which is equal 120 volts over 100 milliamps, where Z total is equal 1.2 kiloohms. But please notice that the answer is not complete. We are missing angle. So in order to find angle, I'm going to use the formula for power factor. Power factor is equal cosine of angle theta, and this is also equal R over Z total. So in order to find the angle, I'm going to take just this part of the formula and solve it for theta. Theta is equal inverse cosine of R over Z total. So this is equal inverse cosine. R is equal 1 kiloohm, and I have Z total equals 1.2 kiloohms. So theta is equal negative 33.55 degrees. Someone is going to ask, how come you know that the answer is going to be negative angle? Because x of c has to be greater than x of l. So if x of c is greater than x of l, your angle is going to be negative. So we found Z total equals 1.2 kiloohms and has also angle negative 33.55 degrees. Okay, so this is my Z total. Next, I'm supposed to find voltage across each component. In order to find voltage across each component, I'm going to use Ohm's law. We have also missing x of c, and we are also missing x of l. So we can find x of c first. X of c is equal 1 over j omega c, which is equal 1 divided by j. Omega is equal 4 times 10 to the 6 radians per second times the capacitance 25 picofarads. Okay, we're supposed to get the value 10 kiloohms and angle of negative 90 degrees. Okay, so this is the capacitive reactance in my circuit. Next, we're supposed to find x of l. In order to find x of l, I'm going to use the formula for series circuit, impedance of the series circuit. Z total is equal R plus x of l plus x of c. So I have Z total with angle, I have resistance, and I have x of c. I can find x of l. So I'm supposed to write that x of l is equal Z total minus resistance and minus x of c. where Z total we found is equal 1.2 kilo ohms and angle of negative 33.55 degrees minus resistance, which is equal 1 kilo ohm, minus X of C, which is equal 10 kilo ohms, and angle of negative 90 degrees. This is equal (9.33 kilo ohms and angle of 90 degrees. So this is the inductive reactance in my circuit. Now we're supposed to get ready to find the voltage across each component. I'm saying get ready because I want to use Ohm's law to do so. And please realize that we have I total, which is equal to IR, but we are missing angle. We have to find the angle for our current. You're supposed to remember the formula which says that I total is equal voltage source over Z total. We assume that voltage source has angle of 0 degrees, and we found that Z total has angle negative 33.55 degrees. So we have magnitude of current given already. This is equal 100 milliamps. And if it comes to angles, we're supposed to simply subtract these two angles. So I have 0 minus negative 33.55 degrees is going to give me angle 33.55 degrees positive. Okay, so this is the total current in my circuit. So in order to find voltage across the resistor, I'm going to write that VR is equal IR times resistance. So IR is equal 100 milliamps and angle of 33.55 degrees has to be multiplied by resistance 1 kilo ohm. This is equal 100 volts and angle of 33.55 degrees. So this is the voltage across the resistor in my series circuit. Voltage across the inductor. VL is equal IL times X of L, where IL is equal 100 milliamps and angle of 33.55 degrees. Okay, this is the same current like I total times X of L, which is equal 9.33 kilo ohms and angle of 90 degrees. This is equal 933 volts and angle of 123.55 degrees. So this is the voltage across the inductor. Next, we're supposed to find the voltage across the capacitor. VC is equal IC times X of C. Again, I have the same current, 100 milliamps and angle of 33.55 degrees times X of C, which is equal 10 kilo ohms and angle of negative 90 degrees. This is equal 1 kilovolt and angle of negative 56.5 45 degrees. Someone is going to say the answers don't look good because you are applying 100 volts and across the inductor you got 933 volts and across the capacitor you get 1 kilovolt. Something is going wrong. I can say that everything is going fine because in future you are going to learn that in series circuit we are going to obtain the resonance at certain frequencies, and because we got that high voltages, it means that we are getting closer to the resonant frequency. But at this moment we just simply calculate the voltages. In order to verify that our answers are correct, you're supposed to simply use Kirchhoff voltage law. So I have KVL says that voltage source is equal voltage across the resistor plus voltage across the inductor plus voltage across the capacitor. Okay, let's check what we're going to get. So VR we found is equal 100 volts and angle of 33.55 degrees plus VL, which is equal 933 volts and angle of 123.55 degrees plus 1 kilovolt and angle of negative 56.45 degrees. This is equal 120.37 volts and angle of negative 0.272 degrees. So as you can see, the voltage is equal almost 120 volts like we had at the beginning, and the current is less than 1 degree. So we can say that we have angle 0 degrees. So it means that our calculations up to this moment are correct. So next I'm going to find the true power in my series circuit. So true power is equal IR raised to the second power times the resistance. Why I'm not using 1/2? Because this time I'm dealing with the RMS values. If you're dealing with RMS values, you're not supposed to use the power formula with 1/2 at the front. So I have IR equals 100 milliamps raised to the second power times the resistance, which is equal 1 kilo ohm. This is equal 10 watts. Okay, so this is the true power in my series circuit. Next, I'm supposed to find the reactive power at the inductor. So if QL is equal IL raised to the second power times X of L. So again, I have 100 milliamps raised to the second power times X of L, which is equal 9.33 kilo ohms. This is equal 93.3 volt ampere reactive. Okay, so this is my QL. Next, I'm supposed to find QC. QC is equal IC raised to the second power times X of C, which is equal 100 milliamps raised to the second power times X of C, which was equal 10 kilo ohms, and this is equal 100 volt ampere reactive. Okay, next we're supposed to find Q total. Q total, use this formula, is equal I total raised to the second power times the difference between the reactances, X of L minus X of C. Supposed to use the absolute value. Now you subtract from X of L, X of C when you do not use the angles. When you are going to deal with angles, you're supposed to simply add these two reactances together. But when you don't write angles next to the reactance and you want to find the total reactance, you're supposed to subtract from X of L, X of C. Okay, it comes from the formula that X of T, right, total reactance is equal J X of L minus J X of C. Okay, if you are going to factorize J, you are going to have J and X of L minus X of C. When we calculate the power, we don't use angles or J's, that's why we simply subtract. We have to find the difference between X of L and X of C. We're supposed to use absolute value because we cannot get the negative power. 100 milliamps raised to the second power times absolute value of X of L, which is equal 9.33 kiloohms, minus X of C, which is equal 10 kiloohms. Okay, so this is equal 6.7 volt ampere reactive. Okay, don't forget about the absolute value. Your answer must be positive. So this is the total reactive power in my circuit. Next, I'm supposed to find the power factor. Power factor is equal cosine of angle theta. Okay, so this is equal cosine of angle negative 33.55 degrees. Okay, this is equal 0.833 lead. Okay, we're supposed to add word lead because I have negative sign next to my angle, which is next to Z total, and because the capacitor has greater impedance than the inductor, and because of it, current in this circuit is going to lead the voltage source by angle 33.55 degrees. That's why I'm supposed to write word lead next to the value of power factor. Now we are ready to find the current in the parallel equivalent circuit. So because the capacitor is taking over the inductor, right? So in the parallel equivalent circuit, we are going to have voltage source, we are going to have resistance, and we are going to have capacitance. Okay, you're supposed to know this from the beginning, since you saw the statement X of C has to be greater than X of L. So it means automatically that in your parallel equivalent circuit we are going to have capacitor. So you're supposed to realize that voltage source in parallel circuit, right, is going to be equal to the voltage across the resistor Rp, and this is also equal to the voltage across the capacitor in my parallel circuit. So, and everything of course is going to be equal 120 volts RMS. Now we're supposed to find the Y total. Y total is equal 1 over Z total. Again, you're supposed to switch your calculators to the rectangular mode in order to obtain the answer in rectangular form. So I have 1 over Z total. Z total is equal 1.2 kilo ohms and angle of negative 33.55 degrees. This is equal 694.5 microsiemens plus J 460.55 microsiemens, where the real part of my answer is the conductance G and imaginary part is my capacitive susceptance. So in order to find the current, I'm supposed to use Ohm's law. Ohm's law says that current, IRP, right? Current, which goes through the resistor in my parallel equivalent circuit, is equal voltage source over RP. But we didn't find RP. What you're supposed to do is supposed to simply write voltage source over 1 times 1 over RP, where RP is nothing else, reciprocal of RP is nothing else, just simply conductance. So I can write that this is equal to voltage source times G, where voltage source is equal to 120 volts times 694.5 microsiemens. This is equal 83.34 milliamps. So this is the current which goes through the resistor in my parallel equivalent circuit. Next, we're supposed to find IC, right, in the parallel equivalent circuit. This is equal, again, I'm going to use the same formula, voltage source times, in this case, BC, right? So I have voltage source 120 volts times BC, I have J 460.55 microsiemens. This is equal 55.26 milliamps. I can write J, but I prefer to use polar form. I'm going to write 55.26 milliamps, an angle of 90 degrees. Okay, so this is the current which will go through the capacitor in my parallel equivalent circuit. Next, I'm supposed to find the power, reactive power, in my parallel equivalent circuit. So in order to do so, I'm supposed to find the power at the capacitor. Okay, so what I'm supposed to do, I'm going to simply write that QP equals voltage source raised to the second power over X of C P, okay? The capacitive reactance in my parallel equivalent circuit. But please notice that we didn't find X of CP. The question is, do I supposed to find it? I can, but I don't supposed to. So what I'm supposed to do, I'm supposed to just simply play a little bit with algebra. This is voltage source raised to the second power over, and don't forget that we found BC. So I can say that 1 over BC is nothing else, just my X of C P. Okay? So if I'm going to use algebra, this is going to be nothing else, just voltage source to the second power over 1 times BC over 1. So I can say that this is voltage source raised to the second power times BC. This is equal. Voltage source is 120 volts times BC. BC is equal 460.55 microsiemens. This is equal 6.63 VAR. Let me remind you that the total reactive power in series circuit was equal 6.7 volt ampere reactive. So we can say that these two values are close enough. We got the difference because, of course, we round off some numbers. That's why the numbers look a little bit different. Next, I'm supposed to find CP, right? The capacitance of the capacitor in my parallel equivalent circuit. In order to do so, I'm going to use the formula for capacitive reactance. X of C is equal 1 over omega C. But again, we didn't find X of C. Instead of X of C, I can write 1 over BC equals 1 over omega C. In order to find C, we're supposed to simply solve the proportion, and we are going to have omega C is equal BC. In order to find C, I have to divide both sides of the equation by omega. Omega and omega will cancel out, so I have CP, because of course we are talking about the parallel equivalent circuit, right? Is equal susceptance, capacitive susceptance over omega, which is equal BC we found is 460.55 microsiemens over omega, which was given 4 times 10 to the 6. 4 times 10 to the 6 radians per second. And this is equal 115.13 picofarads. Okay, so this is the capacitance in my parallel equivalent circuit. So at this moment we can say that the problem is solved.